Download this code from codegive.com, link in the description below. Deep dive into node.js buffer performance and addressing GitHub issue 52, buffer.bytelength, inconsistencies. This tutorial provides an in-depth exploration of node.js buffers, focusing on performance considerations and the nuances surrounding the deprecated buffer.bytelength method, which was the subject of GitHub issue 52 in the node.js repository. We'll cover 1. Understanding node.js buffers *, what are they, why are they important, and their fundamental characteristics. 2. Buffer encodings *, a detailed look at different encodings and their impact on byte length. 3. The buffer.bytelength, issue 52 *, a historical perspective, the problem, and why it was deprecated. 4. The correct replacements, buffer.bytelength versus string.length *, when to use which method and the performance implications. 5. Performance considerations * strategies for optimizing buffer usage for speed and memory efficiency. 6. Practical code examples * illustrating the concepts and demonstrating best practices. 7. Common pitfalls and how to avoid them * addressing common mistakes when working with buffers and encodings. 8. Troubleshooting * tips for diagnosing buffer-related performance issues. 1. Understanding node.js buffers. Buffers are a core feature of node.js, playing a crucial role in handling binary data. They represent a fixed-size chunk of memory allocated outside the V8 JavaScript heap. This allows node.js to efficiently interact with file systems, network protocols, and other I/O operations that deal with raw data. Key characteristics fixed size once created, the size of a buffer cannot be changed. Direct memory access buffers provide direct access to memory outside the V8 heap, reducing garbage collection overhead. Binary data designed to handle raw binary data. They aren't inherently strings, although they can represent strings using various encodings. Encoding aware buffers can be created and manipulated with specific encodings, example UTF-8, ASCII, Latin 1, etc. Immutable, often while the data within a buffer can be modified, the buffer object itself is not immutable in the same way a JavaScript string is. You can change the bytes, but you can't add or remove bytes to change the buffer size after creation. Why buffers are important I/O operations reading and writing files, handling network requests, HTTP, TCP, etc., and interacting with hardware devices all involve binary data. Data processing image manipulation, audio processing, cryptography, and data compression often rely on working with raw bytes. Performance avoiding JavaScript string manipulation for binary data can significantly improve performance. 2. Buffer encodings. Encodings define how a sequence of bytes in a buffer is interpreted as characters. Common encodings include UTF-8, UTF-8 the most common encoding for text on the web and in many applications. Variable length encoding, some characters take up more than 1 byte. ASCII, ASCII a 7-bit encoding that represents 128 characters. Limited character set. Latin 1, ISO 8859-1 an 8-bit encoding that represents 256 characters. Also limited. UCS2, UTF-16LE a fixed-width encoding, 2 bytes per character. Used internally by JavaScript strings. Base 64 represents binary data as ASCII characters. Commonly used for data transfer over protocols that only support text. Asterisk hex asterisk represents binary data as hexadecimal characters. Useful for debugging and representing binary data in a human-readable format. Example, encoding matters. Notice the different byte lengths. UTF-8 uses multiple bytes to represent non-ASCII characters. Latin 1, on the other hand, truncates the higher byte of each character and essentially renders garbage, though the byte length is 4. Choosing the correct encoding is critical. 3. The buffer.bytelength, issue 52. Historical context asterisk in older versions of node.js, the buffer.bytelength method was available as both a static method on the buffer class, example buffer.bytelength, and as an instance method on a buffer object, example myBuffer.bytelength. The problem asterisk the instance method myBuffer.bytelength was deprecated because its behavior could be confusing and inconsistent. It returned the length of the underlying buffer, i.e., the allocated size, rather than the number of bytes used to represent the string when a specific encoding was applied. This could lead to incorrect calculations, especially when dealing with multi-byte encodings like UTF-8. Example, the deprecated behavior. In this example, if you mistakenly used the deprecated myBuffer.bytelength, you would get the total allocated size of the buffer, 20, not the actual number of bytes used by the string hello, which is 5. This discrepancy could cause errors in data processing and network communication. Why it was deprecated and removed asterisk the confusion and potential for errors led to the deprecation and eventual removal of the instance method. The correct way to get the byte length of a string with a specific encoding is to use the static method buffer.bytelength, string, encoding. 4. The correct replacements, buffer.bytelength, versus string.length. Understanding when to use buffer.bytelength, versus string.length is crucial for correctness and performance. Asterisk buffer.bytelength, string, encoding, asterisk. Asterisk purpose asterisk returns the actual number of bytes that a given string would occupy when encoded using the specified encoding. This is what you typically want when you're preparing to write a string to a buffer or send it over a network. Asterisk use cases asterisk. Asterisk determining the size of a buffer needed to store a string with a particular encoding. Asterisk calculating the length of data to be sent over a network connection. Asterisk validating the size of input data before processing. Asterisk encoding parameter asterisk the encoding parameter is essential. If omitted, it defaults to UTF-8, which may not be what you intend. Asterisk string.length asterisk. Asterisk purpose asterisk returns the number of Unicode code points in a JavaScript string. This is not necessarily the same as the number of bytes required to represent the string in a particular encoding. Asterisk use cases asterisk. Asterisk validating the number of characters in a string. Asterisk manipulating strings using JavaScript's built-in string methods. Asterisk displaying the length of a string to a user. Asterisk encoding ignorance asterisk string.length is encoding agnostic. It doesn't care how the string is represented in bytes. Example, choosing the right method. This example highlights the difference. String.length counts the number of Unicode code points, characters, while buffer.bytelength, with UTF-8 counts the number of bytes required to represent the string in UTF-8. Performance implications asterisk. Asterisk string.length asterisk generally very fast, as it operates directly on JavaScript string objects. Asterisk buffer.bytelength, asterisk slightly slower than string.length, as it involves encoding the string and calculating the byte length. However, the performance difference is usually negligible unless you're performing this operation repeatedly in a tight loop. The correct usage almost always outweighs the performance difference. Rule of thumb asterisk. Asterisk if you need the number of characters in a string for user interface purposes or string manipulation, use string.length. Asterisk if you need the number of bytes required to represent a string in a specific encoding for buffer manipulation or network communication, use buffer.bytelength, string, encoding. 5. Performance considerations for buffer usage. Optimizing buffer usage is crucial for node.js application performance, especially in I/O intensive scenarios. Asterisk buffer allocation asterisk. Asterisk buffer.alloc, size, asterisk creates a zero-filled buffer. Guarantees that the buffer contains known data, preventing potential security vulnerabilities. Slightly slower than buffer.alloc unsafe. Recommended for most scenarios where you need a clean buffer. Asterisk buffer.alloc unsafe, size, asterisk creates a non-zero filled buffer. The buffer may contain garbage data from previous memory allocations. Faster than buffer.alloc, but requires careful handling to avoid exposing sensitive data. Use only when performance is critical and you're certain that you'll overwrite the entire buffer with known data. It's generally best not to use buffer.alloc unsafe. Asterisk buffer.from, array, buffer.from, string, encoding, buffer.from, buffer, asterisk creates a buffer from an array, string, or another buffer, respectively. The data is copied into the new buffer. Asterisk buffer pooling asterisk. Asterisk for frequently used buffers of the same size, consider using a buffer pool to avoid repeated allocation and deal location. This can reduce garbage collection overhead and improve performance. Libraries like fastbuffer and pool can help with buffer pooling. However, implementing your own can be complex and can potentially introduce bugs, especially if you don't handle memory management carefully. Carefully consider if the complexity and potential risk outweigh the performance gains for your specific use case. Asterisk avoiding string conversions asterisk. Asterisk minimizing conversions between JavaScript strings and buffers can improve performance. If you're primarily working with binary data, keep it in buffer format as much as possible. Asterisk use buffer methods like buffer.write, buffer.copy, and buffer.slice, to manipulate buffer data directly, rather than converting to strings and back. Asterisk buffer slicing asterisk. Asterisk buffer.slice, start, and, creates a new buffer that references a portion of the original buffer's memory. This is very efficient because it doesn't copy the data. However, be aware that modifications to the sliced buffer will also affect the original buffer, and vice versa. Asterisk use buffer.copy, target buffer, target start, source end, if you need a true copy of the data. This will allocate new memory. Asterisk streaming asterisk. Asterisk when dealing with large files or data streams, use streams. Example fs.create_read_stream, http.incoming message, to process data in chunks, rather than loading the entire file into memory at once. This reduces memory consumption and improves responsiveness. 6. Practical code examples. Example 1, reading a file in chunks using streams and buffers asterisk. Example 2, encoding conversion asterisk. Example 3, writing data to a socket asterisk. 7. Common pitfalls and how to avoid them. Asterisk incorrect encoding asterisk using the wrong encoding when converting between strings and buffers can lead to data corruption and unexpected behavior. Always specify the correct encoding and understand the characteristics of each encoding, example UTF-8, Latin 1. Buffer overflow. Writing beyond the bounds of a buffer can corrupt memory and cause crashes. Ensure that you allocate enough space in the buffer before writing data. Use methods like buffer.write, string, offset, length, encoding, to control the number of bytes written. Verify buffer boundaries and length before write operations. Memory leaks. Improperly handling buffers, especially in long-running processes, can lead to memory leaks. Ensure that you release buffer resources when they are no longer needed. Use streams and avoid loading large files into memory all at once. String length versus byte length confusion. Using string.length when you need the byte length, and vice versa, can cause errors in data processing. Remember that string.length counts Unicode code points, while buffer.bytelength counts bytes. Forgetting buffer.alloc unsafe dangers. Using buffer.alloc unsafe when the buffer is exposed to other parts of the application or the network without sanitizing it first can create security vulnerabilities by leaking private data, e.g. passwords. Prefer using buffer.alloc unless memory performance is critical, and you can be 100% certain you're overwriting the buffer before exposing it. 8. Troubleshooting buffer-related performance issues. Profiling. Use node.js's built-in profiler or tools like clinic.js to identify performance bottlenecks in your code. Look for areas where buffer allocation, string conversions, or I/O operations are consuming a significant amount of time. Memory analysis. Use tools like the node.js heap profiler or memwatch to analyze memory usage and identify potential memory leaks. Look for excessive buffer allocation or buffers that are not being released. Garbage collection monitoring. Monitor garbage collection activity to see if excessive buffer allocation is causing frequent garbage collections, which can impact performance. Logging and debugging. Add logging statements to track buffer allocation, usage, and deal location. Use a debugger to step through your code and examine buffer contents. Benchmarking. Create benchmarks to measure the performance of different buffer operations and compare their performance characteristics. Use a tool like benchmark.js to run reproducible tests. Conclusion. Understanding buffers and their associated encodings is essential for writing efficient and reliable node.js applications. By paying attention to allocation strategies, encoding considerations, and potential performance bottlenecks, you can optimize buffer usage and improve the overall performance of your applications. The key takeaway is to be mindful of the differences between string.length and buffer.bytelength, and to always specify the correct encoding when working with buffers and strings. Avoid the deprecated myBuffer.bytelength. Always use the static method buffer.bytelength, str, encoding. Carefully consider the risks before using buffer.alloc unsafe.